Hey, Vlad here, devinside.com. Welcome to another video. In the previous video, we had a typical introduction to the CATS library with the typical gateway drugs like validated or either, which is actually in the standard library, but you get the point. This video was getting too long, and therefore I decided to split it into two, even though this one is actually also going to be very long. And so today we're going to concentrate on applicative functors. Let's get right to it. This is exactly where we left off in the previous video, and we said that there is a clear similarity between app and flatMap. And so today we're going to play around with this and find out exactly what the similarities are. And we're also going to try to answer the question when to use either and when to use validated, which is a very common beginner question. All right, so obviously you can see that there are some similarities, but it's not really clear which ones, and it turns out that it's actually more visible once you're going to start using them. So we're going to go and start using flatMap first, because I assume that most people are, more people are familiar with Monads than with applicative functors, and then we're going to do app. Okay, so we're going to go back to main, and this is exactly the same project. This is exactly what we have been doing. I'm just going to I'm just going to do that for now. All right, so that we know that the new code is going to be over here. Okay, so what I'm going to do is I'm actually going to import Monad for option, right, from the FP library, right, so from our own, right, so that we can play around exactly with our own. Okay, so this is the typical Monad thing, right? So we're going to have a print line with a full comprehension where we get the 1 from sum1 and we get a 2 from sum2. In fact, I'm going to go and start using the CATS syntax, right? So I'm going to do one sum, 2 dot sum, like this. All right, so we're going to yield 1 plus 2, like, sorry, not 1 plus 2. I'm going to do 1 plus 2, like this. All right, very typical thing. Okay, so let's also do the desugared version, right? Because we want to see the similarities. So let's go and do print line, and we're going to do 1 dot sum, and we're going to do I want to use the syntax that comes from our monad for option, right? So our syntax is basically saying that we need to do flatMap first, right? So we need to do flatMap, and then it takes the 1 dot sum. Then we're going to have the 1 over here. Whoops, I wanted to do that. Okay, and we have another flatMap. We have 2 sum. Okay, so we have the 2 over here, right? And we're going to have the 1 plus 2, and we get exactly the same code. Okay, now again, this is going to be very what's happening? What is happening? We probably need a map. Yeah, so the thing is that usually you would have a map over here, right? So usually you would have a map, and also let me create more space over here, like this. Okay, so this is this is what the full comprehension usually desugars to. In fact, actually it doesn't. I actually made a video about full comprehension a long time ago. Okay, but today I want to show you the similarities between flatMap and app, and therefore we're going to only be using flatMap, right? So we're going to go over here, and we're going to say that this is also going to be a flatMap, and flatMap, it needs to produce a sum over here, right? So in this particular case, I'm actually going to use this syntax, or yeah. Now I don't want to mix the syntaxes. I'm going to do this, okay, like this. All right. So basically, this is like the very typical thing. Now we're going to do the same thing for the applicatives, and it's going to look super weird. In fact, when I was preparing for this video, it took me quite a bit to figure out all the types. All right. So, but basically, the structure is exactly the same. So in fact, I'm going to go and copy that. I'm going to paste this over here. Okay. So everywhere where we say flatMap, we're going to say app. Okay, app, like this. Okay, so I'm going to specify the types over here, right? So this is going to be an int to int. Okay, now the difference is that what this app wants is not a function, right? So we don't have access to this 1 over here, right? So I'm just going to remove that. Okay, so we're calling another app over here, and the types over here are going to be int, and this is where it gets complicated. The other type is actually a function. It takes an int, produces an int. Okay, so we have a sum2 over here, right? Again, we don't have access to this 2. Okay, so what we need to produce inside is a sum, but this is going to be a sum, and in fact over here I'm going to use the regular syntax. Okay, I'm going to use sum of, actually no, I'm not going to do this. Okay, so it's going to be a sum of a curried function that basically takes one of the ints, right? So it's going to be either this one or this one. Then it will produce a function that will take the other int, right? Again, either this one or this one, and in the end it's going to produce an int. Okay, so this is the function that we need to produce over here. Okay, so I'm going to have a bit more space. Well, in fact, I'm going to create more space over here like that and like that. Okay, so over here we need to create this function, and it turns out that it's going to put in the 2 first and then the 1, okay, and then the rest. Okay, so basically this is exactly what is happening over here. And I believe, okay, it says missing parameter type, and this is exactly why I didn't want to mix well, actually this is the opposite of what I just said. I actually want to go and mix the syntaxes. So I'm going to go and say sum over here, right? I'm going to have this thing over here, int like this, just so that we don't have to specify the types like this. All right, so in fact I'm going to go and use the curly brace over here and the curly brace over here so that it's formatted like this, right? So now it's starting to look a little bit more similar, but there is this clear distinction that these guys are not there anymore, and also the types are getting more weird, and obviously nobody wants to program like this, right? So we know that monads have the 4 comprehensions, and we're going to see that applicatives, they also have their own thing, and you know, we're going to get to that in a bit. Now, since the addition on the integers is associative and it actually is even commutative, I would like to sort of prove to you that the 2 is the first one that comes in, right? So let's do console.green plus 1 plus console.reset, and we're going to have a 2 over here. Okay, right? So if we see the 1 first, then it means that this is actually a 2 and this is actually a 1. And this is exactly what we're seeing. Okay, I'm going to remove this real quick. Like that. There we go. Now, first of all, let's convince ourselves that this thing actually behaves exactly like monads do. So let's take the monad one over here, right? And let's go and do a none over here, right? None over here. Then the whole thing, you know, it should be none. Let's say it's a none event. There we go. Okay, and it's none. Then let's copy that. Actually, I'm not going to copy that. I'm going to paste exactly this thing that we had before. Okay, so now if this one is a none, okay, right, also a none, and paste it again. And if this thing is a none, right, so if we don't even have a function, okay, because over here, you know, we're producing a I mean, we have a function, but the result of the function is going to be a none. Right. This is also one of the reasons why I use flatMap and not map, so that I can do this here. Right. So if anything is none, the whole thing is none. Okay. Let's go and do the same thing for this one. Gonna copy that. I'm gonna go and paste this one in, and we're gonna do a none over here. Maybe we actually don't need to specify the types over here because we have the int over there. Right. Yeah. Oh, hello. Let's do this again. Sometimes Bloop dies. I don't know why. All right. So works the same. And if we have a none over here, then it works the same. Okay. And if we have a none over here, I'm going to use none of. Okay, so it needs to be int, like this. All right. So if we do that thing over here, it works the same, right? So in all of the 6 cases, right? So for the monads, if anything is none, the whole thing is none. Same thing for applicative. If some of them is none, the whole thing is none. Now, what's the point of all of this? And the point is that for some, in fact, for quite a lot of problems, applicatives are enough to solve your problem, and therefore there is no need to reach for monads. But not always. Applicatives are not a silver bullet. I mean, there has to be a reason for the monad's existence. Okay. In fact, I chose this specific example in which the in which is kind of hard to see because it wasn't purpose. We're going to do other examples a bit later. All right. So in contrast to applicatives, monads, they have this sort of superpower, right? Because monads are all about sequencing computations. They allow you to have a dependency on the previous computation, right? So there is this notion of previous, right? Because there is this notion of order, right? And let me actually show you this to you. So if we go and do something like, where's our original one? Original flatMap. This one. Okay, this one. Let's go and take it. Let's go down. Let's go and paste it. Okay, so this is the original one. No, this is not the original one. This is the original one, 2.sum. There we go. All right, so that we can have a sum of 3. So this thing, even though it creates its own thing, it actually over here, right? So in this block, right? So, well, technically like from here to here, right? It has access to this 1, right? So just for fun, let's go and do sum 1 plus 1. Okay, still gonna compile. What's happening? Oh yeah, I still need to wrap it into a sum. 1.sum. like this. All right, so this is going to compile, right? It behaves exactly the same as before in this case because I actually did 1 plus 1. In fact, maybe I should do like 1 plus 5, right? So that you don't get confused, okay? The point is that if we take the applicatives, where's the applicative? One, sum, two, okay, this one. Okay. By the way, I'm always saying applicative, but technically apply is enough, right? Because as we have seen, app is defined in apply. Okay, so if I paste this one in, okay, so notice that over here, right? So we had the 2.sum over here, right? So if I do something like that over here, it's not going to compile, right? Because we don't have an access to this one, right? We don't have this one, arrow to the right. Okay, in fact, maybe it's going to become even more clear if I completely take it out. Okay, so for example, I can go and I can grab this whole thing. This whole thing, I can cut it out, and I'm gonna type in independent over here, right? And the independent is going to be just a val over here, independent, like this, okay? And the type of this is going to be just an option of int to int, okay? So it behaves exactly the same, right? You have this sum 3, okay? However, if I wanted to do the same thing for the flat maps, right? So for the monads, take this for the monads, okay, I would be forced to take this whole thing, right, was the 1, right? So if I'm gonna do 1, 2, until here, right, I'm gonna do that, and I'm gonna say dependent, okay, because dependent, right, so we can have all dependent, right, it's gonna be this, okay, it now needs the types, right? So dependent is something that that now needs this integer, right? It needs this 1 so that it can produce an option of int. Did I type this right? Yes, I did. Okay, in fact, like the better way to write this would be to say, okay, this needs to be a def, right? So that this 1 comes in over here, so that this whole thing produces an option of int, right? So the type is like this, and now we don't need this 1 arrow thing. Okay, so maybe now it's a bit more clear, right? So we need to have access to this 1. Actually, it would make more sense if I do something like. Is it going to make sense? No, it's not going to make sense. Yeah, so basically, well, yeah, it sort of makes sense because right now you see that like that this 1, it's just like nowhere near here. Like where should it come from? It's just not there. And also, by the way, because we took this out, this 1 can be like anything, right? It can be, I mean, it has to be an integer, but it can be anything, right? Same thing over here, right? It's anything. Okay. In fact. Yeah, let's do +1 over here. I just want to have a sum 3 all the time. Yeah, it's called anything like this. Did I do it at the top as well? Yeah, I did. All right, there we go. All right, so this is probably one of the most important parts of the video. So monads, in contrast to applicatives, they guarantee order. In fact, one of the things that applicatives are sort of usually being praised for is this ability to compute things in parallel. Because basically, if we look at the definition of app, which is over here. Well, actually, it's more visible over here, right? So it basically says, just give me a bunch of things. I don't care if you calculated them in parallel or not. Once they're all there, then I can do my thing, right? So this is one of the things that, again, like this is like sort of like in the center of this entire video, right? So the computations for applicatives are independent from each other. However, as we have already seen, there are some examples, I created this very, very specific example. There are some examples for which it doesn't actually matter which one you use. And so therefore, you might as well just, stay at the applicative level and you don't need to go down to monads. In fact, this also means that sometimes app can be implemented in terms of flatMap and the other way around. And this is exactly what we're going to do now. So for example, we could actually go over here, right? So let's go and say, so this is an override, and this is an override as well. Okay, so we can actually go over here and we can say that app, for example, is basically just well, actually, we can't call flatMap over here. So let's do it only down here. Okay, so for app, for example, how are we going to do this? Let me copy these two and let me go down like that. Let me remove the overrides and let's say that this is app2 and this is flatMap 2. Okay, so question marks and question marks. Okay, right? So one of the ways to implement app, in some cases, is we could say, let's just call flatMap with f, okay? And inside of it, well, it wants a function that goes from A to option of B. Well, why don't we just say map f of A, okay? Like this. And if this was too fast, you don't really need to understand this. I just want to show you that you can sort of go back and forth, okay? And over here, it's almost the same, right? It's basically like the other way around. So we can call app, right? We can call app with f of A, right? And we will just give it a sum of f like this. However, there's one distinction, right? Because this thing, it will actually say, hey, I found A to option of B. I actually required A to B. In fact, I actually wanted to call the second one like this. Not that it matters. Now, the compiler gets confused a little bit because it infers slightly different types. So if we help it out, basically it wants like A and B over here, but in fact, what is happening here is that we're having an option B over here. Okay, so now this is a proper error. So basically it says like this whole thing now returns an option of B, but we wanted just an option of B, right? And this is a typical thing, right? So if we had a function called flatten like this, right, then we would be able to figure this out, right? So if we have private def flatten, which takes an A, which takes a nested an option of A, right, and then it can produce an option of A, which we're going to implement in just a second, which is super easy to implement. But this thing is going to compile, okay, right? And let's, just because we're already here, let's do nested match, right? And if it's a sum of option of A, well, then just return it, and otherwise just return none. Okay, we're not going to use this implementation anyway. I just wanted to show you that basically in some cases, like it will behave exactly like you want it to do, right? So where you don't need these, this dependency, right? Now, because nobody wants to program like that, like our example over here was these, these nested apps, and nobody wants to do this with Monads as well. Therefore, we have 4 comprehensions, and I'm going to show you like which tools CATS brings to work with applicatives in a nicer way. And in order to do that, we need to talk about a thing called Semigroupal. Okay, a Semigroupal, it basically sits somewhere over here between the functor and apply, and it looks like this. Trait Semigroupal, okay, like this f, and notice that it doesn't extend a functor, right? It doesn't have anything to do with functors. Okay, so this thing has a function called product, it takes A and B, and this one's actually simpler than all the others, right? It takes an f of A, it takes an f of B, like this, and it produces an f of a tuple of A and B. Now, we have seen in the previous video what products are, at least on the conceptual level, right? So these are the Cartesian products, right? Where you have basically all the combinations of f of A and B, and we know that, tuples are, the anonymous products. Okay, so the thing is that apply now goes and says that it's not only a functor, it is also a semigroupal, okay, with semigroupal of f. Now, it shows us that we need to go in to implement a product for options. However, we actually don't need to, because there is a reason why we're mixing semigroupal into apply, because as it turns out, we can actually implement product in terms of app. Okay, so we can go over here, and maybe Bloop can help us out. Yep, product, please. There we go. Product. All right. So now the compiler should be happy, but obviously this will throw an exception. So what we can do is, and it's going to look a bit weird, but in fact it's going to look in the end, right, because like this is what we want to get rid of. In the end, it's going to look pretty much like this, right? So in fact, let me find this one. Let's put a 2 dot somewhere here. Okay, it's going to end up looking something like this. So at some point it's going to have like this thing. Okay, so basically we're just calling app, right? We already have an f of A, so we're going to give it an f of A. Okay, and inside of it we're actually also going to use map from functor. Okay, so we're going to go and we're going to call map. Well, we're going to call map with f of B. Okay, now, and this is the complicated part, right? So this is that thing where this current function comes in, right? So the B comes in, then the A, remember they were swapped, the 2 came in first, then the 1, a B comes in, A comes in, and they're being just wrapped into a tuple. Okay, and as I already said, like applicatives there, or apply in this case, they sort of have this associativity like sort of built into them, right? Because what you could also have done is swap them, right? So you could have said f of B comes in over here, f of A comes in over here. Now this is an A, now this is a B, and we're still producing the tuple in the correct order, right? So this thing is like sort of like the it's sort of like built into them. Okay, and therefore let's just this is more common to use this one. So now we have all of these things, right? So we have the map, we have the product, and we have the app. But it turns out that now that we have product, we can actually implement a funny version of map called map2. Map2 will take like both of these, right? So we can actually go and we can actually put it on the plot, right? So we can go and we can say, so this is going to be a map2. It's not going to take just a and b, it's also going to take a z, right? So z is going to be the result. I'm using z because this is what they use in cats, or z. Okay. All right. So it takes an f of a, right? Same as before, but it also takes in an f of b, right? So it sort of reminds you of the product, and it sort of reminds you of the f, right? So, of the map, right? So a map took only one. Map2 is going to take two of them. Okay, it takes two of them, and now it wants a function. Okay, it wants a function that now doesn't go just from a to b. It actually goes from a to z, but it actually takes a and like both the a and the b, right? So a and the b. In fact, we don't need these extra parens like this. Right, so it takes a function. Basically, it takes both of them. Right, this is sort of like the big notion of applicative. So it basically says, once everything is ready, just give it to me, and we're gonna produce the result. Okay, so it's like this. We don't need this curly brace. This whole thing produces an f of z. Okay, right, and the implementation is basically we're gonna call map, right, the original map, but in order to call map, we need to give it one thing, and this is exactly what product is doing. Product takes two things and makes one out of them, right? So inside of this map, all we need to do is we need to give it a product of f of a and f of b. Okay, and now over here we're going to have a function where a tuple comes in, right? A tuple with a and b, right? And what do we need to produce? Well, we need to produce an f of z, and we have a function that will take a and b and produce it for us, right? So let's just call it a and b. Okay, and so it's like this. And what does it say? Map does not take parameters. It does not. Hold on. I forgot a curly brace over here, regular paren over here, like this. Okay, because it's a curly function. Okay, like this. And now that we have that, we can keep going. We can have map 3, map 4, map 5, right? So let's go and let's have map 3, right? We're gonna have map 3, right? So map 3 is going to have also a c, right? So we're gonna have ABC, right? So we're going to have it over here, right? FC, which is an f of c, like this. This function is going to take three things, right? So this product. Now, this is the funny part, okay? So over here, and this is again like the associativity strikes back, okay? So we can either do a product of f of a of b, right? Like this, okay? And then have comma fc, right? Basically call product again, like that. Right, so product of product, right? Because we have like nested tuples, right? But we don't want nested tuples, okay? So now we need to go and let me figure out which way we have this. I think we have it like this, right? So basically we have like nested tuples, and now they're becoming unnested. Let's see if I did it right. And it looks like I did, right? But again, like associativity is sort of like built into this, right? So you can go and you can do it the other way around. And I believe by default, it is actually done the other way around. So by default, it's, well, not by default, I mean like in cats. So it's a product of f of a, comma, and on here we have a product of f of b. Let's not get lost in these curly braces, f of b and f of c. This is where it ends. Maybe, hold on, we don't need this one. Like this, let's actually comment this one up. Okay, and now they're just associated a bit differently, right? So we have a of b here and bc here, like this, right? So, okay, I did something wrong. This one, okay, one more here. Yeah, there we go. I believe that this is actually like the way to associate them, right? But this notion of associativity is built into them, so it doesn't actually really matter. But I believe that this is how it is implemented in cats, and this is actually what we're going to see in just a couple of minutes. By the way, there are also in cats there are also versions of app like this, right? So there's also app2, app3, app4, but nobody wants to program directly with app. Everybody wants these maps. Okay, so basically this means that what we can do now is we can go and we can say. Over here, we can say print line, and this is this fancy tool that I grabbed in Chimney, right? This apply. So notice that I'm not importing FP library anywhere, I think, right? Hold on, FP library. Okay, I'm only importing the monad for options, so that's fine. But I'm not importing FP library. So this apply is actually apply from cats. Okay, so we're saying okay, so give me apply for option, right? In that video about Chimney, we're actually getting apply of validated nag with some star or something, right? But in this case, it's just option, right? And let's say that we want to, we want to deal with only two options, okay? So like in our case, right? So we can say map2, okay? And then we give it the one.sum. And in fact, let me do this because I want to show you one important thing, right? Sum1 and sum2, right? And now it wants a function where 1 and 2 come in, and now you can do 1 plus 2, right? So this API is already a little bit nicer than before, right? So sums3 comes out the same as was this was this weird where is it? Let me just grab like one of these. Let me grab one of these. Right? So because like in the end, like this is what's happening, right? So map calls product, product calls app, right? So in the end, it's exactly the same code. As you can see, it's already much smaller, right? So the last two are sum of 3. Now obviously if we had 3 things, we would need to say map3. Okay, map3, and we need to give it another sum3, and we would have a 3 over here. Right, we'd have 1 plus 2 plus 3 like this, and a 6 should come out. Well, a sum of 6 should come out. Okay, like this. Okay. Now there's also an even better syntax, and this is where our cat's helpers are going to come in with one.sum, because so the helper is basically like this, right? So let me actually copy the whole thing, and this is the helper that we actually have seen in the video about Chimney, right? So basically, if you have a tuple, right, like sort of like we sort of have a tuple over here, right? Then on that tuple, we would be able to say mapN. Okay, so we can basically throw this thing out, and now we don't need to care about 2 or 3 or 4. We just have a tuple. We're saying mapN, and it's going to behave exactly the same, but it needs to find a functor for option. But in this case, the type that was inferred is a sum, and this is exactly where these helpers where they will come in. Okay, so if I grab all of these, if I do that, and I do that, and I do dot sum, right? This is exactly why they sort of exist. Now it's going to compile and it's going to behave exactly the same, right? So now we can, for example, remove the third one and remove this third one over here, right? The third one over here, but we don't need to switch anything because this mapN, it understands that it's being called on a tuple with 2 things, so it understands that it needs to, in the end, to call map2. In fact, if we jump in it, we're going to see that this is a fancy syntax, and it needs a functor, and it needs a semigroupal, and it just takes the semigroupal and calls map2 because it knows that it's a tuple of 2, just passes everything along. If we jump in there, we're going to see that this is a semigroupal array of functions. So they're not called A and B, they're called A0 and A1, but in the end, it's doing the same as we did, right? So it's doing functor.map, semigroupal.product. This is exactly what we did. We did map, and then we did product. And then, yeah, it basically just reassociates these things, right? So in the case of 2, it's doing this. In case of 3.sum, and we're going to have a 3 over here. Okay, so if we jump into that one, now it's going to be like, this is a tuple. This is the wrong one, isn't it? It's the wrong one. Hold on. mapN. Yeah, so this is the right one. So see, it's tuple 3, so it's calling map3, right? And it's doing exactly the same thing. It has exactly the same pattern match, right? Exactly the same thing. Okay, cool. Let's go back to our example, which is this one. So what's happening very often is that I'm seeing people using monads where monads are not really necessary, right? So they go and do like, 1, and let's take it from this, and let's do a 2 over here. Let's do a 3 over here. Not 300, 100. Okay, so and then they go and do yield. Okay, I did something stupid. This should be 1, this should be 2, and this should be 3, and they go like this: 1 plus 2 plus 3. However, in this case, there's no dependency, right? So this sum has no dependency on this one. So why use for comprehensions, right? You might as well go and use that, right? It's exactly the same thing. And by the way, we forgot the 3. 1 plus 3. Okay, this is even shorter, and sometimes I'm actually very often I'm doing that like that. Okay, oh come on, like that. Okay, it's basically the same thing. Looks very similar. Sometimes it's actually even shorter. We're actually going to get to examples like this. Okay, so basically the point of this video is you don't always need monads. Okay, in fact, you get some benefits if you use applicatives, and these benefits are basically accumulation. This is the the very typical example. So if I go over here and I say, okay, let's not play around with sums. Let's play around with others. Okay, so let's say that this is an actually maybe hold on, maybe I can do something like dot sum, like whoops. Okay, so maybe I can do something like this. Let's say that this was an error 1, 2, 3. Okay, and over here we're going to say left neck of int. Okay, left neck like this. All right, so this is an either has a monad, and therefore basically it fails fast, right? So it short circuits and it doesn't even execute all of the other code. However, if you do the same thing right over here, right, and you go and use invalid neck instead, then the benefit that you get is, well, first of all, that it doesn't compile, right? It doesn't compile because it doesn't have a monad. However, you can very easily rewrite this, right? So instead of this 4, right, you can basically just remove the 4, replace this brace with the opening brace, like this. This one is going to be the closing brace, right? The yield is going to become mapN, and usually you would do like, dot mapN. Okay, over here you're going to have the function, and this is going to be the implementation of the function, right? So over here you're going to have the function that takes the 1, 2, 1, 2, 3. Okay, over here you don't, because you're using 1, 2, 3 over here, you obviously don't need them over here, right? So we can do this and just do that, and now all we need is a comma in the end, and Scala FMT is going to remove the last comma for me. Okay, so this is basically essentially the same code, right? We're not using either, we're using the validated. However, we're getting this accumulation of the errors. However, like this is the point, right? So either it has a monad, but every monad is also applicative. So if we were to go and to use the applicative syntax for monads, right? So if we do this, but we're actually going to go and use left neck over here, left neck. Okay, then we're getting the same behavior as we were to get with for comprehension. So, if you want your things to short circuit, fine. You still, this is not the goal for comprehensions. Okay, so you can still use the applicative syntax, and which will allow you to actually jump between either and validated, right? So it's a bit more flexible, right? So it allows you to jump between, right? So this is sort of like, I don't want to say that this is better, but especially if you're not sure if you want to use either or validate it, go with, start with the syntax. Only if you see, okay, you actually need the dependency or you actually need the order, then go for monads. Now, I want to also show you a bit more in depth, like what is happening over here, right? So basically what is happening is that because every monad is also an applicative and there is a monad for either, right? So either has a monad. Product is being, you can think of it as it is being overridden. Okay, overridden in such a way to behave consistently with flatMap. So what we're going to do now is we're going to go to FP library. We're going to grab a product, and we're going to go and pretend as if we're implementing product for either. So how we're going to implement it, and this is again, like this is one of those things. Product means both things are there. So let's just go and pattern match them, right? So we have f of A, we have f of B, and we're going to have a match. Okay, and we're going to say, okay, so if both of them are valid, right? So we have a value of A, and we're going to have a value of B, okay? Well, then just have a valid of the tuple, right? So this is what we need to do, right? Inside of the product, this is what we need to do. We need to construct the tuples, okay? Now we're being warned that we are not finished with our pattern match, right? So what if it's invalid with some errors, but the other one is valid, okay? Well, then we're just going to produce an invalid with errors, okay? Like this. The same thing for the other way around, right? So if the valid is on the left, right, like this, okay, then we're going to do the same thing. And the last one is exactly why we're here, right? So basically, if both of them are invalid, then we have errors A and errors B. And what are we going to do? Well, we're just going to put them all together. Errors A plus plus errors B, right? So this is the reason why the errors are being accumulated behind the scenes for validated. However, if we're doing either, in fact, let's actually do flatMap for either first. Okay, so if we have, let's copy flatMap. Why am I blind? There we go. flatMap. Okay, flatMap. Okay, so if you were to have flatMap for this thing, let's also create an either errors or. So this is an either neck. Okay, so if we have this over here, either errors or, okay, then we're basically going to pattern match on f of a, which is going to be either, so either it's valid, right? So either it's a valid a, well, then we're just going to apply, we're just going to do that. And if it's invalid, case invalid, with some errors, well, then we're just going to do the same thing, invalid errors, like this. Okay, this should be fine, right? No? Why am I doing valid and invalid? So this is the right and this is the left. Okay, like this. Okay, should be fine now, almost. What is happening? Yeah, so now it's confused with this flatMap. So I'm just going to call it flatMap 2. Okay, so notice that the point is that inside of the flat map you don't have access to this other b, right? So you don't have access to the other errors, and therefore it's basically on purpose that if you're defining a product, let's call it product 2, for other errors, right? Like this, right? Basically every valid becomes right, and every invalid becomes left, right? So even though we could implement it like this for either, it's been done on purpose to stay consistent with flatMap, that we don't actually care about this one, right? So it's been done like this, right? And this is why the errors for others, they don't get accumulated, because it needs to be consistent with the monad. And by the way, for this combination to work over here, we had lists, so we had something that needs to be able to combine. We basically need to ensure that our others, that they have a semigroup for for the error type, not a semigroup a semigroup, right? Because semigroups bring this combine operation. So basically we can go to our main and we can do something like this, for example, right? So if you go and paste that at the bottom over here, right? So the last thing that we're going to see now is going to be a bunch of errors. Okay, so we're going to see a chain of we're using left next. Let's go and use invalid NAC. Okay. So we're going to see the chain of error 1, error 2, error 3, because there is a semigroup for chains, or in this case not empty chains, but that's not the point, right? But if we remove NAC, right, which means that on the error side we're going to have just strings. Well, there's also a semigroup for strings. All right, so the strings are just going to be smashed together. Okay, this also means that if we have something like I don't know, let's have some like case object whatever, okay, and we're going to go and say whatever invalid. Okay, so we're going to say whatever over here, we're going to say whatever over here, and we're going to say whatever over here. Now it's going to say that it can't find an instance of Semigroupal. I'm sorry, could not find an instance of, yeah. So it says that it cannot find an instance of Semigroupal because it cannot find an instance of Semigroup for whatever. In fact, let me actually show this to you, right? So it's going to be horrible, but it's going to work, right? So if you have an implicit val of horrible but compiles, and we're going to have a semigroup of whatever dot type, right? Because it's an object, okay? Then because it's a sem type, it's a type with only one with a single abstract method, which is called combined. We can actually just give it a lambda, which takes whatever 1 and whatever 2, and we would need to combine them somehow, and we're just going to do this, right? So it doesn't probably doesn't abide the associativity laws that are required by a semigroup. Notice again, it's a semigroup, not a semigroupal, but it compiles. Okay, so essentially we have a semigroup, and therefore we have a semigroup for whatever, and therefore we can have a semigroupal for, in this case, either. So essentially, again, I probably said this already many times, you can essentially use the applicative style. It's called applicative style instead of Monadic style sometimes. In fact, I prepared a special thing for you. So we're going to go over here. We're going to save this as I'm going to call it flexible error handling, like this, right? .scala. All right, so I prefer to do it like that. Package like that. Okay, so this is going to be a trait called flexible error handling, like this. Okay, so it's going to be parameterized with error and with the mechanism, right? So you will be able to plug in here either or a validated. Okay, so it's going to be a mechanism with 2 type holes. Okay, 2 type holes like this. Inside of it, just for convenience, we're going to have, like, this whole thing is about convenience, right? We're going to have a thing called multiple errors or a, okay, equals a mechanism of non-empty chain not non-empty chain. Why would it complete non-empty chain to non-empty chain ops? Okay, so let's just do cats data like this. In fact, let's import everything. Import cats and import cats implicits like this, and usually we do it like that. Okay. Okay, so non-empty chain over here with an error and an A. Okay, now technically this thing is already enough. It just said I went ahead and I also included a couple of helpers. In fact, I'm going to copy paste them because it's not vital to understand them for this video. Basically, I sort of copy pasted them from cats and I adapted them to the fact that we already know the type of the arrow. Okay, so it's going to look very kind of weird. Okay, but basically what it will allow us to do is if we have a good type, we will just be able to say dot good on it instead of saying, dot pure. And on the bad type, instead of saying, raise arrow and wrapping this thing in a non-empty chain, we will be able to just say bad. Okay, so let me show you how this thing is used. So we can go over here. And we can, in fact, this video is getting way too long. In fact, I'm thinking that I should probably just go ahead and copy paste this for you guys. Okay, so I'm gonna have an object called business logic. Okay, and this is your business logic, so you know which kind of error handling you want to have. Okay, so basically we're gonna have two helpers. Okay, so we're gonna have a type called dependent error handling. Okay, it's going to be flexible. Maybe it cannot complete this. Yes, it can. Flexible error handling of string and other, right? And we're going to have the same thing for the independent one, right? So independent error handling. Okay, and in this case, it's going to be a validated. Okay, right? Because remember the second parameter over here needs two type holes. It's exactly either and validated. Okay, right. So now I'm going to paste this thing, right? It's called business logic, right? I'm going to collapse it real quick. So let me save it and collapse it. Okay. So in this business logic, what we're going to have is we're going to have a final case class person, and it's going to have a first name string, and we're going to have a last name, which is also going to be a string. We're going to have an age, which is an int. Okay, so in this case, what we're going to do is business logic is going to validate this person, right? So this is a clear validation example, right? Which means that in this example, in this case, you should probably go and use validation, but we're going to use it for both, just as an example. Okay, so the idea is that it's going to have a function called a safe person comes in and a safe person comes out. Safe person looks exactly the same, right? I don't want you guys to be afraid to create case classes that look exactly the same as the others, right? Because like you're creating basically more type safe code. It's not going to be much boilerplate. And if you do end up having some boilerplate, then you can actually go ahead and use something like chimney. By the way, you're seeing some shadows in my faces because I was, I'm sitting in front of a very open window, and it was so sunny today that my camera actually overheated. So I got the blinds, I covered them a little bit, and so you kind of see these shadows. But I'm not the important part. The important part is my screen. All right. So now this whole thing composite. So basically, we're gonna go and we're gonna collapse that. We're gonna collapse. Okay, there's nothing to collapse. Basically, we have this safe first name. String comes in and multiple errors or string comes out. Remember, multiple errors it is over here. Multiple errors is just this mechanism, which in our case is validated. Which one did I pick? I picked the dependent one. I want to pick the independent one. Okay, independent one is the one was validated. Okay, so yeah, so basically it either returns a validated knack of strings, right, by just saying bad, or it returns a valid string in this case. Okay, so basically they're all the same, right? You're basically saying if last name is empty, blah, 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 then, last name must not be empty. For age, just making sure that it needs to be positive. And you're using these helpers. You're saying good or bad, right? And the whole point is that this code works for both string and validated. Okay, so let me show you safe because it just stays at the level of applicatives, right? So remember, validated does not have an instance of a monad, but we're not using anything monadic over here, right? We're just using the same thing as we have always been using, right? So just calling safe for, all of these things, putting them in a tuple, calling mapN. And this is, by the way, where we also saving a little bit on boilerplate, right? Because safe_person.apply has exactly the same signature as what mapN requires. Okay, so this whole thing works like this and also like this, right? So you don't need to change any code. The behavior is obviously different, but you don't need to change any code. Okay, so let's do the independent first, like this. Let's go and let me collapse it. Let's go and do some like print line, business logic, dot save, and we're going to give it a person with everything invalid like this, right? And the other one is going to be the proper person. For example, we're going to do Bob Marley. Hopefully, I'm spelling his name correctly, but Marley, and we do 36. Okay, so the first one is going to accumulate errors, right? Because we have independent error handling, therefore we have a validated, right? So we have a bunch of errors over here. However, if we switch to dependent error handling, we're going to use an either. Either is going to short circuit, and it's going to give us only this one error. Now, the point is that very often people don't know which one to use. Should you use like either or validated? And what it turns out is that they pick the wrong one, and then a bit later they want to change it to something else. However, if they pick either, most of the time they went and used for comprehensions even though it wasn't necessary. As of right now, we're using an either. I'm sorry. Yeah, we do. We're using an either. However, we're staying on the applicative level, and so we're using the mapN, right? So we're using the applicative style. So in this case, if you see, maybe you learned a little bit more. Oh, actually, if I switch it to validated, I'm actually going to have all the errors accumulated. You won't need to change much code. Okay, independent like this, right? And now everything is accumulated the same as before. And now the sun came out again. All right, we're pretty much finished with this video. I'm just going to show you a couple of more sort of things that are very, very related to applicatives, right? But essentially, I already made my point. Okay, so one of the things is that, some people get surprised when they see this behavior, right? When they see, okay, let's have a tuple, and let's say that we have a list of A, B, and C, okay? And we're going to have another list over here with list of 1, 2, 3, and they do mapN, and they do a C over here, N over here, C over here, N over here, right? Arrow to the right, and they have C, arrow to the right, and like this, okay? And some people get surprised that what comes out of this thing is a Cartesian product, right? But this is exactly what it should do, right? So mapN should compute the Cartesian product. The thing is that it's not too crazy to expect that in this case, mapN should behave as a zipping of the two lists. Okay. However, the way I explained it to you, it shouldn't be surprising, right? Because it should behave consistently with monads, because list has an instance of a monad, and therefore the product is implemented exactly in such a way as with monads. Okay. So, for example, if we go and we do a print line, and we're going to have a for comprehension over here, right? Where we have the C comes from this first list. Okay, like this, and the N comes in from the second list, like this. 1, 2, 3, and if you yield, right, the same tuple, right, you should have exactly the same result, because the implementation should remain consistent. Look at the list. There we go. Okay, so it's not only about short circuiting or things like this, right? So it's the fact that it needs to stay consistent with monads. Now, a tiny other thing, we're going to get back to this example in just a second. I just want to show you that in this case, if you look carefully, if you look closely, in this case over here, we're actually this function. It looks exactly the same as the apply function for tuple2. So we can actually go and do tuple2, and this is a very common use case. Okay, tuple2 char end. Okay, and another way to write this is basically just by saying tuple2.apply, and then in this case we wouldn't need to, well, actually let me actually do that. Okay, dot apply, this is another way, apply. Okay, but it turns out that this use case is so common that there's actually a function also in cats that basically does exactly that. So instead of mapN dot tuple blah blah blah, you can just say dot tupled. Okay, exactly the same thing. As you can see in the print lines, it's doing exactly the same thing. It's just a very, very common thing, and therefore you have this function in there. Now, again, let's go to this example over here. This one, all right? So again, it calculates the Cartesian product, okay? However, sometimes you would want it to just zip the lists together. And the way you do this is by calling another function called par_mapN. Okay, and this function uses something else in cats. In fact, this is a little bit more advanced than everything that I've shown you today, but essentially it's not that complicated, and I'm going to explain it to you in just a second. So similarly to mapN, which comes from apply, right? So it's a fancy syntax for apply. par_mapN comes from a fancy syntax from a type class called parallel, and parallel is a type class which is a bit fancy again, but it's actually not that complicated. So essentially it exists for things that have a monad, but you want them to behave in such a way as if they didn't have a monad, right? So essentially, par mapN looks for so mapN, it looks for an instance of well, technically Semigroupal and a functor, but essentially it looks for an instance of apply. And par mapN, it looks for an instance of parallel. And parallel will also have an instance of a product, and it will override it in a different way, right? So it basically allows you essentially to have a different implementation of product, which in this case is just a zipping, or in case for eithers, there is also an instance of parallel, which overrides product in such a way that it actually puts the errors together, right? So if we go to where do we have this? Where do we have this? This one, for example, right? So we're going to have an either that will be actually able to combine the errors together, right? So I have this either over here, right? So let's see. Right? So we have a chain of error 1. However, if we just go and use par mapN, right? Par mapN, okay? Then we actually ended up having an either where the errors are still accumulated, which is super, super cool, very, very useful, very, very cool to know about. One of the last things that we're going to do today is we're going to talk about essentially nested applicatives and nested things in general, right? Because it's a very common thing to have like methods that don't just return either, they return a future of either or some effect of either, okay? So what we're going to have is we're going to have a final case class report, which takes in some days, right? And we have earned, right? So anytime you have some sort of reports, think of Monads right away, right? Where you aggregate reports together, right? You putting them together. So we're going to have an example where we're doing a print line over here. Let's say we're going to have 2 reports. We're going to have 10 and 100, and we're going to say a valid nag of string, and we're going to have a comma over here, and we're going to have 200 here, 200 over here, okay? Now let's say that we're doing, mapN, and over here we're going to have first report, and we're going to have second report, and we're, basically putting them together, right? Report of, where days is going to be, first report, dot days plus second report, dot days, and we're going to have earned is going to be first report, dot earned plus second report, dot earned, okay? Like this, right? Nothing too fancy. Basically, typical reports accumulation, right? So we put 2 reports together, we get a report, for more days, for a month in this case. However, as I already mentioned, most of the times you're gonna have them in the future, for example, right? So let's do Scala dot concurrent like this, and we're gonna have Scala dot concurrent dot duration like this, and we're gonna need implicit val EC, which is a Scala concurrent dot execution context exactly global. Okay, like this, right? We're also going to have a tiny helper. We're going to have a helper called await result, which is just going to take a future of a, produce an a like this, and just going to call await dot result future, and you're just going to fix it to 5 seconds like this. All right. So let's say that we're going to have this thing, and we're going to paste it over here. And we're going to say that this is not going to be just reports. We're going to say that these are going to be futures of reports, right? Future of report like this. And over here as well, future of report over here as well, right? Now, this thing is obviously not going to compile because like these things, they're not reports anymore, right? So they're now, it's like one level deeper, okay? So essentially we need to like sort of like cut this thing out like this, and we need to say dot mapN, and we need to say whoops, sorry, okay, cut this thing out, and we need to say that this is going to be a first validated nag, and this is going to be a second validated nag, okay, like that. Well, actually, let's say first validated and second validated. Right, so let's remove the next like this, okay, right? And inside of this, now we can actually paste this thing back, and well, actually, still not yet. Okay, so we still need to put them in a tuple, right? First validated, okay, and second validated, and now we can paste this thing back in, right? And do that. Okay, so now we basically have this sort of nesting, and we're gonna see examples of how to deal with this nesting. Now, if these were monads, the way you would deal with that is by a thing called monad transformers that many people frown upon, but for simple things like this, they're actually very, very useful. And applicatives have transformers as well. However, monads don't compose that well, and applicatives compose way too well. In fact, it's disgusting how well they compose. No moderation, like rabbits. And therefore, there's only one transformer out there that can compose all the possible applicatives, right? So what you can do, and this transformer is called nested, what you can do is basically, so let's grab this one again, okay? Rip this one again, go down over here, okay? And let's say that this is, okay, let me save. So again, let's say this is a future report, okay, like this. And this is also a future of report like this, right? And now it's not going to compile, okay? But what you can do is you can just go and wrap them into nested, and over here also nested, right? So if you're familiar with monad transformers, basically the same concept, but the only difference is that there's only one transformer out there that is necessary, and it's called nested. And also there's a helper function, so instead of like doing it manually like this, whoops, like that, you can just go over here, and you can just say dot nested. Okay, so this is much shorter, right? So it will remove this sort of nesting for you. In fact, I haven't been watching this. We actually need to go and use my my helper, this await result. Okay, so we're gonna have a await result. We're just gonna put this whole thing in there, await result like that, and the same thing over here, right? I'm gonna have a await result like this, right? So that I can show you that exactly the same thing is being computed. What's up? Wanted as future of any. Oh yeah, one important thing about nested, we need to go and at the bottom we need to extract it out, right? So it's the same as with monad transformers. We need to get them out again. Okay, so yeah, so as you can see, all of them compute exactly the same result. I also want to show you exactly the same thing with monad transformers. This is not a tutorial about monad transformers, and also I'm going to paste it from a script. It's basically going to look exactly like this, but it's going to use an either, and also it's going to use a full comprehension because of that. Okay, so I'm going to paste this in. Okay, it looks very, very similar, right? So instead of nested, we have either t, right? Instead of validated, NAC and invalid NAC, we have the right NAC, right? We have a full comprehension, we have this thing, and we have dot value in the end, right? And exactly the same thing comes out. And the reason why I'm showing you this is that because you can actually use both of these things together, right? So so instead of using a transformer, right? So let me actually copy that. Okay, so instead of using the transformer, you can actually remove the transformer, right? So like this and like that. Okay, like that and like that, and we don't need the dot value over here, right? What you can do over here is basically you can go and mix it in with the applicative, right? So you can go over here and you can say, okay, let me put them into a tuple, and this is what I'm seeing most of the time. And this is a very useful pattern, because you might have a full comprehension with a bunch of things, and then in the end you still want to sort of like combine all the errors. Okay, you do this, right? You do this, and then you do mapN. Okay, and then it needs a function, so this curly brace needs to be over here. Right, so now it needs a function that takes this one, and it takes this one, okay, and arrow to the right. I forgot the arrow. Okay, right. So this is basically exactly the same thing as with the transformers, but without the transformers. Okay, so in the end, the same thing comes out. In fact, maybe yeah. So this is with the transformers, a little bit shorter, right? And this is without the transformers. Over here we use the transformers because we were using an either. Over here we can use the same syntax for either and for validated, right? So it doesn't. So the only difference is that if the errors are going to get accumulated or not. Okay. So if this is a left NAC, then the same code works, but the errors don't get accumulated, right? Because again, it's an either. However, if you do invalid NAC, exactly the same code works. Right? Because with the monad transformers, this code would not work, right? You cannot do a monad transformer with it validated. Okay. So again, like this is like the point where the applicative syntax is more flexible, and the monads are more constrained, which is sometimes something that you need, something that you want, because you can. We had talked about this in 2 videos ago. If things are more constrained, then they're more predictable, right? You can reason about them more. This is a classical mathematical trade-off between flexibility and and what? Well, constraint. I think the trade-off is between power and flexibility. Anyway, you get the point. One last thing to point out is that over here we're using a for comprehension, and still we're getting the errors accumulated, and we're getting the errors accumulated because every time you use futures in the functional world, you always want your futures to complete, right? They should never throw exceptions, right? So if you have an error, it still should be a successful future, right? Therefore, there's no like there would have been short circuiting if futures would fail, but these futures, they never fail. Okay, if they fail, they actually succeed with an error inside of them, right? This is why we're actually getting this accumulation, right? So I didn't want you to get confused. All right, one last thing, and I know that this video is getting way too long. Whenever you have this feeling that you look at your for comprehension and you see, okay, you have a bunch of things that don't depend on each other, and you're thinking like, oh, Vlad made this video about applicatives, I'm going to go and rewrite this into applicatives. Please don't forget that monads they sort of bring two things, right? They bring this dependency, but they also bring order, right? And for this, I'm going to show you a very small example. For this, we're going to need an IO monad, because over there we're not going to have a dependency, but but the order is going to be very important. And for that, we're going to go into the build, and we're going to go and we're going to say that we also want org.top level, same thing. I should have duplicated the line. So we're going to do a cats effect, and I believe the latest one is 0.0 like this. Yes, please import the changes, and we're going to go into main, and we're going to go to the very top, and we're also going to say import cats effect implicits. I think that should be enough. All right. So now we're going to go and we're going to have a super simple example of an IO program. Okay, so we're going to have a program which is an IO of unit. This is a classical example. We're going to have a for, and we're going to have this, right? And like that. Okay, so we're going to have IO of printline of what's your name. Again, this is a classical example, and then we're going to have the name over here, and we're going to have IO dot standard in dot read line. And by the way, Bloop is actually not good at this, right? So it can't it can't do this. So we're going to need to switch to SBT real quick. In fact, maybe I should start doing this. Okay, let's go into SBT. All right, so we're going to have an IO of print line over here, and we're going to have a string interpolation, and we're going to say you entered name like this. Did I do it right? It looks right. Okay, so now we're going to yield that. Okay, and let's go and print line these things. Okay, and if I did everything correctly, it should compile, but it shouldn't do anything. Okay, we probably need IO as well, so we probably need also, let's actually cut this out and bring it down. We might actually not need implicits. Okay, I think this is enough. All right, so let's go and run this thing. Okay, it's going to compile for the first time because all this time we were actually sitting inside of Bloop. All right, so but once it finishes compiling, it should not run this program, right? So this is IO. This is this is a description of the program. So if you wanted to run it, we would actually need to go over here and say unsafe run sync in this case. Okay, so now it would actually run this problem. And why am I showing this to you? I'm showing this to you because if you look at these two lines, you don't see the dependency, right? You don't see that this value is being used somewhere over here, which is why we're also using the underscore. Okay, what's your name? My name is Vlad, and you see this weird amp thing because we're using the continuous running. Okay, what's your name? Vlad, you entered Vlad. Okay, cool. So we don't see a dependency here. We don't have a dependency here. However, we need this order. And therefore, if you go and rewrite this to applicative style, at least like this part, you can actually rewrite to the applicative style. You might lose this order. In order to demonstrate this to you, let me actually show you something else. So let's say that we have an example, and this video is getting way too long, so I'm going to show you. Okay, let's not run it for now. Let's actually go and do some stuff before. Okay, so let's say that we have this. Okay, let's actually go back to running. Okay, so let's say that we have this. There is a special form of app, right, or the special form of mapN that basically allows you to do something like this. It allows you to call mapN, but it basically knows that you're going to throw everything out except for the last thing. And also there's a version for the first thing. Okay, so and if you have like only one thing, basically you will be able to run just map. So this fancy syntax goes like this, right? So you just copy that, you go over here. All right, so basically you're going to end up having only one thing over here, right, which is the third. And because it's only one thing, you don't need mapN. You can just use the regular map, because that thing that you're going to have inside of here, it's not going to be a tuple anymore. It's going to be, in this case, what is it? Validated. Okay, so basically instead of the commas, you just go and you do star and the greater symbol, right? It sort of looks like a weird arrow, right? So basically it's exactly the same as what we had before, right? Was mapN, but everything else is getting thrown out, and you're getting only the last one, right? So we have the valid 30, which is just the last one. The other ones are getting thrown out. Okay, so you can have also the same thing with the first one, right? So let's say that this one returns the first one, right? And let's go and copy that and go that, right? So see, it returned to 10. So if you want the first one, okay, then we need to basically switch this arrow, right? We need to do to the left and remove that thing from the right. Okay, if you don't like this symbolic thing, the arrow to the right is called productR with a capital R, right? So this is a productL, for example, productL. Okay, so if you prefer this, but basically it's sort of like with the arrow, it kind of looks more natural. And the reason why I'm showing you this is that because you might actually go into that thing that we have over here, and this is a very typical thing that you would sometimes see, is that instead of like having like these things, you're just gonna copy that, comment this out, and we're gonna do this arrow, right? So like this, and like that. Okay, we're gonna do this thing. Okay, so it behaves exactly the same. All right, so if I uncomment this, right, and we're gonna go over here, I'm gonna press enter so we don't have this weird thing. Okay, now I'm gonna run this program, and it's gonna behave exactly the same as before, I believe. No, it does not, because I ruined it. Hold on, let me type something in. I ruined it. I wanted it to have it the other way around. See, that's exactly the point. It's a bit confusing. Like this. Okay, so run. Okay, what's your name? Vlad. You added Vlad. Okay, now if you comment this out, I'm gonna duplicate this line, and if we reverse them, right, so basically sort of like I had them before, right, so sort of like this, right, and now you can use like the other arrow. Okay, like this. So this code is going to compile. In fact, let's go see. Okay, so this code is going to compile. In fact, like in my opinion, actually it reads kind of nicer, right? Because you kind of see the flow of here, right? So this happens first, and we have the arrow to the left, and this happens then, and we have the other arrow to the left, and this thing happens, then it goes from here. You kind of sort of like can read it from right to left. However, it is not going to behave the same, right? So if we run it, see, it actually wants the input first, right? And you can say Vlad, and then it's going to print out this, and then it's going to say you entered Vlad. Applicative does not have to guarantee anything to you, okay? So this thing is happening first. This thing is happening second. However, the effect of this is being thrown out. I'm sorry, not the effect, but like the result type, right? So the unit over here is getting thrown out. Remember, like the first is just being ignored, and the third, or in this case, the second, is the one that is being returned, right? Which is in this case is a string, which is also why this whole thing compiles, right? It compiles, but it doesn't behave like you want it. Okay, so be very careful, right? When you're looking at a for comprehension, and the for comprehension looks as if it doesn't use this dependency, and you're like, oh, I'm going to go and rewrite this into applicative style, make sure that the order is also correct. Okay, so the for comprehensions, they kind of guarantee it for you, right? Because Monads guarantee it for you. But if you're choosing to go with the applicative style, be sure to ensure it that it behaves like this. And also write unit tests, because again, someone can go in cat and change the order, right? Change the order there, because it expected you to give it something that is associative, but you didn't, right? So yeah, I just wanted to advise you to not like go and rewrite everything in applicative style in a hand wavy way. As I already said in the very beginning, I had a very, very specific example which we could rewrite with any of style, because the order didn't really matter. Right? In this case, the order matters. Great. So now you can go and re-watch my video about Chimney, and you're going to understand it without any issues. And as always, I'm sorry that this video got way too long. It's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on Patreon. But most importantly, take care.